I'll introduce myself a bit more in a minute, but I'm Paul Grenier. Thanks for coming. The first thing I want everybody to bear in mind is that we are all here to have fun. Now, I appreciate I haven't done any icebreakers yet, none of you are giggling yet, but I will get you giggling soon, I hope. So I don't know who this guy is, but I was at a tech leaders conference a few weeks ago, and something like this slide came up, and it reminded me that we're all here to do stuff, but we're mostly here to have fun. And those of you that have worked with me, Alex, will know that I like to have a lot of fun on my team. So tonight, we're here to have some fun. Right. So about me, most of you probably know. I think I know most of the people in the room. So I'm a husband and a father, and I always make the joke that my wife says I have to put that first, mostly because she's over there. Yeah. I've been a software engineer for a very long time. Alex was just saying that he thought I started work in the 90s, but I'm not that old. Used to own a business. I'm currently a team lead. I was one of the founders of Norwich and obviously Norfolk developers. Massive heavy metal fan, science fiction, Formula One, all the cliched stuff for software engineers. That's me. I used to have long hair, but it's now falling out. And I'm a reluctant cyclist. Basically, the doctor told me that I needed to get more exercise. If you're a Strava person and you'd like to follow me on Strava and you're quick enough, there is a QR code just there. Got it? Cool. And yeah, I'll skip this slide because Victoria's already done it. Did anybody here I wrote a book? Yeah. Oh, come on, warm up. I was expecting a bit more of a laugh than that. Did anybody hear that I've written a book? Ah, this is going to be a difficult audience tonight, isn't it? Right. So I have written a book, and there are some for sale at the back, but there's no pressure. Let me know if you're interested. So tonight I'll do your deal. If you stay for the first half, okay, and you enjoy it, great. If you think it's rubbish, just stay for the first half, and nobody will notice if you just slip away in the interval. Is that okay? Good. Right. So tonight I'm going to talk about what a service is. I'm going to talk about monoliths and microservices, scaling services, all of those things you can see there. I'm going to do that in the first half, in the first 45 minutes. Who saw me do this at NordDevCon this year? Cool. Who didn't see me do this at NordDevCon this year? Ah, good. So at least some people. Weren't you there?
You were talking.
I thought you were.
That's so embarrassing. I did for.
It's more embarrassing for me because you didn't remember. So yeah, so let's start off by talking about what a service. Oh no, sorry. In the second half, we'll look at sharing data, caching, testing, exception handling, and logging. Okay. Tell me. Okay, fine. Now, so has everybody seen? There'll be lots of cultural references. Has everybody seen Pirates of the Caribbean? Anyone not seen Pirates of the Caribbean? Good, you're already better than the Colchester lot because not one of them has seen it. So one of the things that I'm going to tell you about tonight are things that I think you should do. Okay, but with most things in software engineering, they're not rules. Okay, they're just guidelines. So there's this bit in the film. This isn't actually the bit in the film. It's just the meme that came up where Keira Knightley is all excited. She's going to get one over on the pirates because of the pirates code. And Barbossa turns around and says, no, they're more like guidelines. Okay, so what I'm talking to you tonight, that they're guidelines, but I think you should do it. So let's start off with talking about what a service is. And the way we're going to do that to begin with is about what a service is not. Okay, so a service is not code that just runs on a server. Okay, it's not interchangeable with a web application or a mobile app. Those things aren't services. And it's not a class or a function that encapsulates business logic. Service is one of the most overloaded words in software engineering, but it's none of these things. Nothing we're going to talk about tonight is one of these things. Although we do touch on the class or function as encapsulates logic as a service a bit in the second half. So it's important to think about what a service does and what it's responsible for when we think about what a service is. So this guy, Chris Richardson, I found his book brilliant for microservices, but he also has a great bit about services in the book, which describes what one is for me. So a service is a standalone, independently deployable software component that implements some useful functionality. Okay, so that's we think about services as doing something which is useful. And we're going to talk about microservices and we're going to talk about monoliths shortly, but it's really important to understand again what they are doing. And so Chris Richardson introduces this idea of business capabilities. I mean, it's not his idea. It's used in lots of places. It's a distinct cohesive function within an organization that delivers specific value to customers or the business. Okay, so that's what a business capability is. So for example, you might have order management, you might have payment processing, you might have customer profile management. They are all business capabilities. So a service is something, for some reason, my notes here are really small, which is why I'm looking up here and reading off the slides, which I'll continue to do. I might even stand up in a minute. So we've already talked about what a service isn't. Okay, we know it's not We know it's not a web application. We know it's not a mobile application. Usually they operate behind the scenes. Okay, a service is normally doing something in the background. They rarely operate in isolation though. They're always talking to something, a database, other services, front-end applications, what have you. Usually has a well-defined, well, always has a well-defined API. We'll look at some APIs later on. And they're independently deployable. So you should be able to take your service and put it into production without having to think about other things at the same time, okay? I appreciate in practice, especially with microservices, that often isn't the way, but that's how it's meant to be. And a service is a lot like an object in object-oriented programming. So it's cohesive, encapsulated, and loosely coupled. So cohesive, all of the things that change together and are related are together. Encapsulation, you can change things behind the scenes without affecting your users and your clients. And it's loosely coupled, so that if you want to change one part of the service, it doesn't affect another part of the service. So they should be like that. And then each service can have its own tech stack. So if you've got multiple services working together, they can be in lots of different languages. Everybody with me so far? Good. No questions? No one? No? Good. Wonderful.
There is a question.
Yep. Hi, David.
Order service, is that like another name for a web API?
No. It's so if you think about a company that sells tea and coffee, you know, you go and place an order for tea and coffee, that sort of thing. Yeah.
Oh, I see.
Are you thinking more order? Yeah.
The procedure of the
Yeah, it's a business capability. Yep. Cool. So databases. So most services, not all, but most services will have a database. They've got to do something with their data. It needs to be persisted. What you shouldn't do is share databases between services, because then they become coupled and you make a change for one service in the database and it breaks the other service because it's not expecting it. So we'll talk about sharing data later on, but one thing that services must never do is share a database. So let's have a look at monoliths versus microservices. Who knows 2001: Space Odyssey? Can I show of hands? Yeah, good, because you're all quite quiet. So, so when you have a monolith, this, for those of you who haven't seen 2001, this is the monolith, which is a block of what they think is stone that appears on the moon, and they don't know what it is. And then by the time you get all the way through, it's changed the solar system entirely. So with a monolith, all of your business capabilities are in one service. Everything's in one place. The entire system runs usually in one process. So you've got one code base and you've got one database. The advantage of this is that it simplifies development and deployment. Everything is in one place. So if you make a change that in one business capability which affects another business capability, you've got all of the code in front of you. And so which makes it much easier to change. But they become harder to maintain over time because all of that code together becomes coupled, and you change something in one place and it ends up with an unexpected consequence in another. And unless you think about how your monolith is structured to begin with at the beginning, it's difficult to break it up later on. If you don't think about how you're going to possibly break it up later on, you end up with something called the distributed monolith, which is where you've broken your monolithic code base into a number of different services, but they're still coupled together because they were once one, and there's no proper separation. So every time you have to deploy one service, you have to deploy another, and changes in one service still affect directly the changes in another. So make sure that you avoid the distributed monolith. And of course, the other bit of 2001 is, I'm sorry, Dave, I can't do that. What you shouldn't do is do the distributed monolith. So let's have a look at microservices. So microservices, if a system that consists of independent services, I bet if I move this over, it'll get bigger and then I can read it. Magic, right. So microservice basic systems consist of smaller independent services, right? So you've got your different business capabilities in services. So you have an order service. I forget what the other things I said were, but all of those different business capabilities will be in different services. So yeah, single business capability per service. You'll have APIs. So the services can talk to each other and talk to other things, and that might be RESTful, as we'll talk about at the end of this section, or it might be message queues. And there's a distinct tech stack. So if you want to, you can do one of your services in Node, you can do another one in .NET, and if you really have to, you can even do one in PHP. Yeah, so you have a distinct tech stack and database. Yeah, so any database you like in any tech stack, as long as they talk to each other nicely. And they're independently developed, easy to scale, and easy to deploy. And there's a complexity shift between microservices and monoliths. So monoliths concentrate all of their complexity in one code base, whereas Microsoft's microservices distribute it right across all the services. And there are more challenges. You have to think about how your services are going to communicate because you've got more than one of them. You have to think about how data is going to be consistent, and we'll talk about that in the second half. And you have to think about how you're going to deploy them as well, okay? Because you often have multiple instances, as we'll talk about in a minute, of your microservices, and you have many microservices, and sometimes you have to roll them all out together, although in theory you shouldn't. And the way you manage that complexity normally is often making your team more complex. So platform engineers, DevOps and SREs, everyone know what an SRE is? Site reliability engineers. So where I am, we have platform people who build the platform, they look after Kubernetes, they look after everything around it. And then we have site reliability engineers who kind of bridge that gap between software engineers and platform people, like DevOps used to be, and they help us get our services out into Kubernetes, for example, and keep them running. So a lot of the complexities can be managed by your hosting provider. I've said Kubernetes quite a lot. Kubernetes is great. I love it. It's brilliant. It allows you to run things and scale things really easy. But you do need careful planning and robust automation, because there's a lot to do and you don't want to be doing it manually if you don't have to. So when I started writing this presentation, I decided I was going to find out what the perfect size was for a microservice, so I could tell you all what the perfect size was for a microservice. And I found this guy, Jamie Nagays, who reckoned that the Goldilocks zone, you all know Goldilocks, right? Yeah, too hot, too cold, just right. Yeah. He reckons that the right size for a microservice is 100 to 1,000 lines. Well, I don't know about you, but I couldn't do a lot with 100 lines, not in a service. Probably do a bit more, just about enough in 1,000. It depends what you're writing. I mean, we have a service at Haven that sends emails. Quite a simple service. Just listens to a queue, takes emails off the messages off the queue, passes them onto another system. That's probably only 1,000 lines or thereabout. And when they're this size, they're easy to scale and change, but it's not a hard and fast rule. So I thought a bit more about what size microservice should be, and it's not really about lines of code. So you should just have one business capability, as we've talked about in a microservice, and they should be small enough for one team to look after. Yeah, they should definitely be small enough for one team to look after. In practice, my team looks after about half a dozen microservices, so it can vary. And they should be independently deployable, and the sizes vary. So an order service that's got all of your stock in it and knows how to create an order and perhaps knows how to dispatch an order is going to have a lot more code in it than the email service that I just described. So, with a lot of things, the size of a microservice depends. So generally speaking, you shouldn't share code, and I'll talk about that a bit more in the next slide. You shouldn't share code between microservices, but there are some things that need to be done all in the same way, so it makes sense to share the code. So all of your microservices should authenticate in the same way, they should all log in the same way, observability should be the same, the resilience patterns should be the same. So those things which are genuine cross-cutting concerns, they're not part of your domain, they're other stuff that your service has to do. Those can go in shared code, and you should write it in a shared library, store it somewhere, and then deploy it to integrate it to all of your services. But what you mustn't do is share your code, your domain logic between services. If one service needs to do something that another service does, you don't put it in a library and then share the code. You create an API and you expose that functionality. To the other services. The code is just in one place, so it only needs to be changed in one place. But there are some exceptions. You might have your domain objects, your entities, okay, which are just plain old classes of some sort or plain old data structures of some sort, no business logic at all. They are likely to be the same across your microservices, so you can share them. And sometimes you might write helpful libraries. So for example, the email service that I was talking about earlier, it's got quite a lot of complex setup to get where the queues are and other bits and pieces. So we've written a library that does all that setup for you, and we share it amongst our other services. So what I think you should do is always start with microservices. And the main reason I think you should always start with microservices is I think they're fantastic. So once I got into microservice, I absolutely loved it. It's brilliant. Does anybody prefer monoliths? Yes, so start with microservices unless you can't. So you need to keep it under constant review. There are lots of reasons why you might not want to start with microservices, and cost is often a big one. Complexity is another. Think about maintainability. One day you might have to break it up into microservices. So avoid that distributed monolith we were talking about earlier. Compartmentalize your monolith so you can split it up into microservices easily. Yeah, which then gives you the modular monolith. Sorry, the reason I've left Kevlin up here is because those of you who came in and saw me at NordevCon give this, he was giving a talk all about modular monoliths just after I was speaking. So I was rather hoping that he would say, and I didn't know at the time, I was rather hoping he'd align with what I was saying, because if I didn't align with what he was saying, it would be me that was wrong. But fortunately, he did align with what I'm saying. But I've keep him up here because Kevlin's one of my favourite people. And if you're not connected with him on LinkedIn, you don't follow him, you really should. Cool. Right, let's talk about scaling services, and let's have another cultural reference. So I'm a bit more confident of this cultural reference because a film featuring this person has just come out. Who knows He-Man? Yeah? Ah, good. Right, so He-Man, I have the power. So there are basically two ways of scaling services. One is vertically, and that's basically where you just give it more power. More CPU, more RAM, faster storage, all of that stuff just to make it go quicker. But eventually you will hit various limits when you do these things. Again, some of them can be cost. There's only so much RAM and CPU that you can give something. That's becoming less and less true. Okay, but there are times when you want to scale horizontally instead of vertically. And unfortunately, I haven't got a nice cartoon character for scaling horizontally. So scaling horizontally is where you have more than one instance of your service. Okay, so that if one of your service instances is busy, then messages can be processed by the second or the third or the fourth, or however many it is you need. But this introduces some more unique problems, because you have to make sure that your messages go between the different services. Okay, and you have to be ready for one service getting the first message in the sequence, and a different instance of the service getting another message in the sequence, and the states not being shared between the services. So you have to make your services stateless. What you can do is put the state in the database. I look like I've lost a few people. Yeah, you all with me? Okay, cool. So this means you need to think about how you're going to make things stateless, and what you might or might not want to store state-wise in the database. And you have to think about how you're going to load balance the messages, whether you use a round-robin approach or some other approach. Right, observability. Who uses Datadog? No? Sumo Logic? One person? So what are other people using for observability, for log monitoring, that sort of thing?
Azure application insights.
Yep.
We use gas most of the time.
Yeah. So if you're old like me, then you've probably had SSH terminals or SSH sessions into lots of different servers, trying to work out how the message has gone from that server to that server by looking at the logs, and none of it's correlated. So now we have these we have these aggregators, for want of a better term. So they're bits of software where you can just send your logs off, and they will aggregate them together, so you can see what's happening right across all your different services. Something like Datadog allows you, with a correlation ID, to chase a request all the way through from your web app or your mobile app, through your services, into other services, and even down to the database layer and back. So you can see exactly what's happened and everything that's in the chaining of events. So things like Datadog, they're not cheap, but Datadog in particular is really good. And it's there for your metrics, your logs, and your traces. So we've got an intern at the moment, and she's fantastic. And she's just been to the Datadog Day in London, and she did a presentation this week on it. And she made me think differently about metrics, logs, and traces. And I wish I'd written it down, because I've completely forgotten what she said, but I'm going to try and remember. So she said metrics are when something has happened. Okay, so you might be measuring your orders, and you can see there's suddenly a drop in orders, so something might have gone wrong. So that's when something happens. Your logs are about what happens, so you go and look at your logs to find out what the error is that's caused your orders to drop. And then traces are about where it's happened, so you can follow the requests all the way through and seeing what's going wrong. So yeah, observability is really important with microservices. Let's talk about public API. So I think it is really important that something external to your system, like a web application or a mobile application, because that's running outside of whatever your services are running on, it's really important that it only speaks to one service. And the reason that it's important that it only speaks to one service is that you've got a single point of entry, and your web application or your mobile app doesn't then have to orchestrate lots of different services. So if you want to move one of your services, then you would have to change all of the clients. If you want to change anything else about your service, you might have to change all of your clients. So what should happen is your mobile app or your web app should talk to this one service within your system, and then it should orchestrate to other services. The other thing, of course, is if you orchestrate multiple services from your web app or your mobile app, you've then got to think about your distributed transactions and how you're going to roll back when something goes wrong. And
that creating a single point of failure? But if you cascade.
Well, so again, we're back to how much of your app is going to work if one point doesn't, if one of the services isn't there.
Consistency.
Exactly. Yeah, it's a single point of failure, but we've got our horizontal scaling, so we've got high availability and all those sorts of things as well. So if you're doing distributed transactions and you have to roll back, that's then on the client. Okay, it's outside of your system. Okay, it's on someone's phone, it's on their machine. You're out of control. Okay, they could do something could vanish. You can't reliably roll back your transactions. So by encapsulating everything you can inside your system boundary, you reduce the problems there. And then you need to think about how you authenticate your services with each other as well. So between services within your system boundary, you should use an API key, okay, because it's nice and simple. There doesn't have to be a user present. You don't have to look up anything. You don't have to rely on another service to provide your authentication. And once you're inside the system, once your client has authenticated, okay, you should trust them at that stage. The authentication happens at the system boundary. And then externally from the system, you then use something temporary like a token. So somebody logs in and they're given a token back, which only lasts for so long. And that token is used into that one service, and then everything else is trusted from that point on. I've seen a number of services that rely on temporary tokens. Okay, and then one service wants to talk to another service and requires a temporary token, and it's a background process and there's no user. So where does the temporary token come from? Yeah, so it's important that we think about how we authenticate.
Like a service principle, then they're almost, if the inter-communication is trusted,
yes,
but the external communication has to come from an authenticated token from the user.
Yep, exactly that. There are some trains of thought. We think, why bother with API keys inside your system boundary? Okay, if someone's got into your Kubernetes, someone's broken into your Kubernetes cluster, for example, you've probably got bigger things to worry about than which services they can call. But sometimes there are some services that you don't, another team service you may not trust so much, and you want to be able to control that. Obviously, I can't give any examples of that. Let's talk about asynchronous communication. We touched a little bit with David earlier. So RESTful APIs, or APIs in general, are one way that services can talk to each other. But sometimes you don't need a response straight away. Well, I've kind of already explained it with the Open API example, which actually I think would be a better example if I change this talk again. So sometimes you don't care about getting a response straight away, so you can put a queue. So for example, the order service may take something from the inventory, send out a message to say it's created an order and what's on the order, and the inventory service is listing, and it reduces the number of that thing in its list of inventory. And the same with the billing service. You might just get a load of line items sent to your billing service, and then when it's finished, the billing service sends it off itself. The order service doesn't need to know about that. It's just looking after orders and it's sending out events. I don't feel I'm explaining this very well. But yeah, so that's asynchronous communication. We do quite a lot of this at Haven so that we can keep our service running quickly while background processes are listening to what's happening. So I'm going to get on my soapbox now, because I fundamentally believe that a lot of people don't understand RESTful interfaces. Are people familiar with RESTful interfaces? Yeah, I'm getting some nods, some blank looks. No one's asleep. No. Right, so a RESTful API is an interface that two computer systems use to exchange information securely over the internet. So that's how AWS describe what a RESTful API is. And they basically consist of two things. So a resource and an identifier. So a resource is anything you find on the internet. It could be a document, video clip, could be an order, could be an email, could be anything. It's something you want to ask a service for and get it back. And then the identifier tells you where to find that resource. Okay, so it's the URL to get into your service, to get your orders, to get your emails, to get whatever. What's really important in REST is consistency. I suspect we've all seen REST APIs where some of the identifiers are plural and some of the identifiers are singular. Okay, in some cases the URLs aren't consistently put together. Sometimes the query parameters aren't consistently put together. So the reason I've got the current year as the example there is we had an API where, again, third party, obviously, where the current year, if it was null, it meant null. and in another endpoint in the same API, if it was null, it meant the current year. And sometimes there was confusion about whether you should provide it or whether you shouldn't. So it's really, really important to be consistent. I'm sorry about the quality of this picture. It's also really important to document. None of us like doing documentation, do we? But it's important to document, even internally. Okay, if your service is being used by another team, another squad, document your API. And if you're selling it to customers, obviously document your API. It's quite easy. Who knows Lord of the Rings? Yeah, we all know Boromir? Come on, you lot. And I know it's late and it's Thursday. Right, okay, great. Right, so yeah, there are two hard things in computer science: caching, validation, and naming things. Right, so it's really important that your identifiers are consistent. You can have plurals, or you can have singulars. Okay, it doesn't matter, but you be consistent. Always be consistent. Even if you're getting multiple orders, if you stuck with singular, stick with singular. If you're getting one item and you've gone for plurals, then stick with plurals. Make it consistent so the API is consistent. It doesn't matter which one you choose, right? But we all know singular is the best way, right? Headers and identifiers. So one of the things you get, especially with microservices, you often don't know who's calling your service. And that could be a problem again if you want to move a service, or you want to change something, or it's the pipes behind the bar. Yeah, you might want to move your microservice. You might want to change something, and you need to know who's calling it. I quite like the idea of just turning a microservice off and seeing who shouts, but the business doesn't like that very much. So often you can find that something is calling it, but you don't know what. But if you've insisted that whoever is calling you specifies the X app ID header, and you return an error if they don't provide it, then you will always know who's calling your service, because they will have to do that. Know your verbs. Yeah, how many people have seen post used for delete? Yeah, or post used when somebody actually means put or something like that. So know your verbs. Get is for getting a resource. Post is for creating a resource. Put is for updating a resource, and in certain circumstances, creating a resource. Okay, so if you want to create something, or if you want to update a resource or create it if it doesn't exist, then it's okay to create using put. And the important thing about put is that it's the entire resource. Okay, it doesn't just let you update one part of the resource. You have to specify the entire resource, and it's updated in your system. If you just want to do part of the resource, then you need to use a patch. That's what patch is for. And then delete wasn't widely supported by Microsoft for many years. It's going back a while now, but now everything supports delete. So if you want to delete your resource, make sure you use the right verb, not a post and not something else.
Can I ask you, what's the performance gain on using the correct verb? Is it a performance gain? Is that the reasoning?
No, it's not a performance gain. It's part of the
Documentation.
Yeah, exactly. If someone knows how it's meant to work and it works a different way, then yeah, there's confusion. Responses. So again, responses tend to get quite cluttered. So there are only a few things that should be in your response. So the resource that was created or updated or edited, and you might want to return the URI where that resource is at. If there's nothing to return, for example, you've deleted something, then don't be afraid to return an empty body and use the correct status code, which is 204 no content. Sometimes responses do need to include other things. Sometimes there may be so many entities that you need to return that you have to page them. So obviously you have to put the paging information in there. There should be nothing else. There's no point in doing this. Okay, if you've got an identifier which says you're getting a user, you know you're getting a user, so you don't need to wrap your response in another user. It's just verbose and unnecessary. Custom errors. I'm not so sure about these ones these days. Since I first wrote this, which was some years ago now, I'm not sure that you do need a description of the error as well as the error code. But if you do have things that aren't covered by your status codes or regular errors that you might return from your endpoint, make sure that you have custom errors so you can say exactly what's gone wrong. It can be useful for humans to have something to read as well, but often they can get what they need from a well-named error code. Something in the business logic may have failed, okay, and you may want to report that, which doesn't mean the request has failed, but the business logic has failed. What I would argue, and I spent a long time trying to find something that supported my argument, believe me, is that the whole request is what the status code is telling you about. So the request was successfully received, it was understood and accepted. The key point is accepted, the business logic has accepted it. At the end of the day, it doesn't matter too much, and these are guidelines. But in my experience, it's definitely easier to be able to rely on your status code rather than have to look in the body to decide what to do. Hello.
This is really interesting. Yes. So we have a lot. So downstream APIs is a big one for me because where I'm trying to get heads around if you make a request to your backend and that backend goes and calls some other enterprise API.
Yep.
And that API works out for some reason. Do you turn like a failed request, failed number and say it's coming from your API? Because your request worked, right?
Yep.
But it tried to do something, and that was interesting. And we were trying to figure out for ages. And in the end, we went to what you were saying. I forget what I think it's like 4 or 9 or something. Whatever the downstream one is. And we said, because again, I think the way you phrase it's like it's what you care about is whether the thing you wanted to do works.
Exactly.
What you don't care about is the internal implication of that backend API.
Yep.
Like that makes more sense. And then you're kind of conceptualizing it as like you're calling a service, not just a server.
Yep.
Yeah.
Yeah, absolutely. So as a caller, you don't care what happens, right? Once you've made your call to that initial service, what goes on, you don't care about. But remember, I was talking about Datadog and how it follows a request right from the web app all the way through to the various services and back. I mean, that's your unit of work, isn't it? As you say, that's the thing you care about, whether it all worked or part of it failed, then everything should fail. So yeah.
If you go to a restaurant, a cafe, and you order a cup of tea, and they say, "Here's the mug. There's no tea." You're like, "No, I don't care. I just want to."
Yeah, it's completely failed. Yeah, exactly that. I love tea. I'm gonna take that. Thank you. Right. So, do you know, I used to have an app for finding tea, and I used an example later on, but it wasn't very good, and people kept picking holes in it. So just for this session, I've changed it. So I'm not going to get to tell you about my tea app, which is a shame. But that's by the by. Right. Know your response codes. Right. It's really easy, and someone's already picked me up on the right response code for a response. It's really easy just to do everything as 200 when it works, but it's also important to understand what's happened for the client to understand what's happened. So know your response codes. Right. 200 is okay. 201 created. Accepted. I'm the service, I've taken the request, I'm going to go off and fulfill it, but I'm not going to tell you about it later. No content, nothing to respond, there's been a delete. Multi-status we'll talk about in detail in a moment. And then bad request. So you've given me crap. Yeah, that's what a bad request is, generally speaking. You've given me something and I don't understand, go away and fix it. Not found, you've asked me for something that I can't find. And conflict, 409. So there's something further down the system. You've given me some data which doesn't match with the data I've got. There's a problem, so I'm not going to do anything. And then your 500s, your internal server errors. Now, I've made the mistake I often make of explaining all of these, and I'm going to go into them in a bit more detail. So, 400. Make sure you know what has actually gone wrong and what the user should do about it. And then 500s are when something unexpected has happened. Yeah, you've run out of memory. The service further down the line doesn't work. Something else is going wrong. And the reason it's really important, and often people do 500s across the board when they should be using some 400s. But the thing is, with a 400, it's saying you've given me crap, go away and fix it, right? With a 500, you're saying something's happening to me, come back later and retry. So if you've got an automatic retry mechanism, which is quite important in microservices, for example, then you don't want to be retrying your 400 because nothing is going to change. It's always going to fail. But equally, if you've got a 500, you do want to retry. So it's really important to make sure that you have them. So now, sometimes you will make a request and it will go away and it will process multiple things, and some of them will fail and some of them will succeed. And when that happens, you need to use a 207, because it's like we were discussing just now. Has the whole call failed, or has just part of the call failed? And if just part of the call has failed, then you return a 207, and the individual parts of the call you then put in the response with their own status code, so you know which bits have failed and which bits haven't. Yeah, okay. So yeah, we talked about our success responses. I've already been through them, so I won't go through them again. Same with our client responses. There's a few more here. Know the difference between unauthorized and forbidden and not allowed. Again, people often just stick with unauthorized. They don't think about whether it's forbidden or not. 500 errors, again, something you run out of memory. Well, if you run out of memory, the chance of you being able to give a response is probably quite low, but something else might have gone. The database might be unavailable. That's a 500. 504 is a gateway timeout. Yeah, if you're a service, you're unlikely to know that you've timed out because you're too busy timing out. So that's normally given by Kubernetes or whatever else is orchestrating your services. The same with service unavailable. If the service has died, you don't know you've died. So whatever is wrapped around you. So I've seen you, David. Whatever is wrapped around you will send that back instead.
Would you still expect to see 500s in production. 400s shouldn't happen in production unless there's something broken big time. I suppose 500s shouldn't really happen in production either. Is that right?
Well, neither of them should happen ever, ideally.
True.
I can show you some screenshots from Datadog which say we definitely get 500s in production.
But on the other side of the coin, we'd be saying we expect them to happen in development.
Yeah.
Okay.
But the thing, especially with 400s, is you've got users. Okay, and users can make mistakes. They can put in the wrong password. They can put in something else that isn't valid. And yeah, in certain circumstances, you can validate all of that in the UI, and it never gets to the service. But often you want to return this in the service.
No,
Oh, was it? Oh, okay.
slightly more philosophical. Right?
Right. Okay. So those are our status codes. I've completely lost where I am now. Right. So what's the most important status code of all? Anybody know? Normally people get this.
404.
You think 404 is the most important?
The teapot.
Anyone who doesn't know about it,
The teapot. Cool. Right. So this was an April Fool's joke that got into the standard and stays there. When we have an internal endpoint on one of our services that we don't want people to call from outside, we give them a 418. Cool. So that's the end of the first part. So we've talked about what's a service. We've talked about monoliths and microservices, scaling services, observability, public APIs, asynchronous behavior, and restful behavior. Are there any more questions?